Good morning, this is EE542 Lab2. My name is Zhen Gong.
I'm Yuelun Yang.
Today we are presenting an experiment on network performance. First, we would like to test latency between the two computers. Let's pin. And we got 0.5 milliseconds from between the machines. And let's do a perf speed test. Let's do a TCP one first. Okay, we got 939 megabits per second. And then UDP one. Okay, this time we will achieve the 186 megabytes per second. Let's do some kernel parameters change and let's see their effects. First, we add a 100 milliseconds delay. Let's do a pin test again. Okay, we can find that latency between the machine has increased to 100 milliseconds. Then let's do another hyperf test. Let's do a TCP one this time. Okay, this time we found the bandwidth has been decreased dramatically to about only 130 megabytes per second. And now let's get rid of the limitation. So now the QDisk parameter is the default one. Okay. Now let's use the ETH2 to limit the link speed. This time let's limit it to 10 megabytes per second and at full duplex mode. Okay. And this time it shows 10 megabytes per second speed. Now let's do another speed check. Okay, we have the typical pin delay, and let's check the iperf for TCP. Okay, this time we got a bandwidth of 9.6 megabytes per second. So the physical link speed has is consistent with that. Now let's do some works about the network buffer size. Okay, now what we got is the default parameter for the network buffer. Let's increase that the maximum size for that to a larger number. Okay, we increased both the buffer size to 2 megabytes, and let's do another speed test. This time I will reset the Ethernet speed to the default one, the 1000 megabits per second at full duplex mode. Okay, still the typical delay between two machines, and let's do a hyper. Okay, and let's add some delay to that. Okay, and now the delay has been increased to 100 milliseconds again, and let's see the effect on the hyper speed test. Oh, this time the hyper result is still not good. Let's try to add the window size to the let's get 128 kilobytes window size.
Wait.
Okay, the server is ready. This time the result is also weird, and we only got 17 megabits per second.
Oh, you need to set it to 2 megabyte, 2 M, not 128K.
Okay,
Yeah, 2 M.
let's increase the window size much.
Yeah, this one is better.
Okay, this one we got better results from the bandwidth test. So after we lift the upper maximum size of buffer size and increase the window size for hyper, we got higher bandwidth under the same condition. Okay, let's remove that delay and use ETH2 to limit the link speed again. Okay, let's pin. Yeah. Oops. Five. Oops, the network got disconnected accidentally on my side. Let's try to plug in the cable again. Okay. Okay. So let's check the current config for the network adapter. Okay, it's now 10 megabits per second. Let's try to do a perf now. Okay, since the link speed is quite low, so we could still reach the maximum bandwidth at this circumstance. Okay, let's reset the link speed back to 1000 and proceed. And
the next experiment is use -W button to change the window to 64, and we can do that.
Okay. Since we have already raised the network buffer size, so we can now just add a simple parameter. So that's
64K as the window size.
Okay, now with the TCP window size of 64 kilobytes, we got 919 megabits per second. And now let's try another one of 256.
256K.
Okay, sir. Okay, this time we got 940 megabits per second. That's a great improvement. So let's proceed. We have already pinned each address to another.
We have to set a 25 millisecond delay.
Yes. Do TCP disk. Now the network latency between the machine is 25 milliseconds. That's pin. Yeah, okay. To ensure the change is effective. Okay, it's 25 milliseconds. And the current link speed is okay, it's 1000 megabits per second. Okay, so let's use iPerf to measure the bandwidth again. First, still a TCP one. And with the 25 milliseconds delay, we got 722 megabits per second. And okay, then let's try to do that in UDP. Okay, this time we have sent a great number of packets. Yeah, what's your bandwidth shown on your laptop?
It's 455 megabits per second.
So this time the UDP
It's even lower.
yes is
Okay. So now we set the send and receive window size to very small. Let's try 1K.
okay.
So we use TCP and 1K window size.
Okay. Are you ready?
Yeah.
Okay.
We can see the bandwidth is very, very small now.
Some of the intervals it even reports 0 bits per second.
Okay.
Okay. And on my side, it shows only 181 kilobits per second.
Okay. So now we do experiment on lossy environment. So we use NetM to set a lossy environment.
Oops, we have to change the. Okay, let's check. Okay, now the 0.1% loss is effective on the Ethernet interface.
And then we use the iPerf to test the bandwidth again. TCP, right?
TCP
Yeah.
this time with the default configuration. This time there's not so much performance loss.
Can you double check the lossy things set correctly or not?
Yes, the loss is 0.1%. Or maybe let's do a UDP one. So
Okay, let's try UDP one. Yeah, we can see there's like I can see there's 1%, 1/10 of 1% packets randomly drop, but this doesn't impact the performance very much. Still reasonable. Okay. So we can verify that. Okay. So
now let's
do secure copy.
Yes. Let's first to set the network speed. speed 100 megabits at few duplix. Okay.
You have to remove the delay.
Oh yes, thank you for reminding me that. Okay, now we have the default network with configuration, and this time we got 100 megabits per second speed. Okay, let's got some temporary files. Let's went to the temp directory and get some random bytes from the urandom. Data.bin. Oh. Okay. Now we got 200 megabytes file, and let's send that to Yang's laptop. Okay. Okay, it's finished. It used 17 minutes seconds to transfer the whole file at a speed of average 11.2 megabytes per second. That's close to the 100 megabits per second upper limits. Okay. So now let's try to have 50-second delay.
50 milliseconds.
Oh, sorry, it's 50 milliseconds.
Yeah. And try SCP again.
Delay. Okay. Okay, it's add device. Okay. So okay, we are 50 milliseconds from Yang's laptop, and let's do a secure copy again. Oops. Okay. Now this time is much slower. We got 10.3 megabytes per second, and transfer this file in 19 seconds. It's a little
Now we can set delay back to 0. There is a little bit drop in performance, but it looks like there's a limitation built in SCP because SCP has encryption, and that's probably the bottleneck.
Okay.
Now we set the delay back to 0.
We have changed that to a lossy
environment, yes. So
Okay.
let's try 0.1% loss and do SCP again.
Okay, please enter your password. You should set up a certificate for that.
As we can see at 0.1% loss, the performance is still reasonable. And then we set a 5% loss.
Oh. Okay, let's do another field transfer. Oh, now the transfer speed is almost 1/3 of the maximum one.
And we can see the performance about 3.8 megabytes per second.
So,
and that's all the demonstration. Thank you for watching.
okay,
Bye.
bye.